Welcome back to Inclusive Design 24, brought to you in partnership with Barclays Access, the Paciella Group, Intopia, Microsoft Edge, and Open Access Technologies. Don't forget you can subscribe to Inclusive Design 24 on YouTube by visiting youtube.com/inclusivedesign24 and hitting the subscribe button. Don't forget to follow ID24Conf on Twitter, and if you have any questions for the presenters, tweet them using the ID24 hashtag, and we'll ask them at the end of the session.
Next up, we have Marcos Caceres talking about how web payments will make paying for things more accessible on the web. Over to you, Marcos.
Well, thank you very much, and perfect pronunciation of my last name. That was really good.
I've been practicing.
So yeah, today I'd like to talk to you about web payments, which is a suite of APIs and formats that we've been cooking up over at the W3C for, I'm going to say about 3 years now. So I personally, tell a little bit about me. So I've been involved with this payments effort for about 2 years now. So I work for Mozilla on Firefox, and my main role and responsibilities is working on web standards. So I worked on things like Web Manifest, and why that's relevant is like all these suites are all supposed to work together with existing, basically with the existing web, with HTML and so on. So I'll go into that. Cool. So buying and selling stuff. As you can imagine, as human beings, we've been trading and buying and selling stuff from each other for millennia. So we kind of understand to some degree how to buy and sell stuff. Like I have a good or a service that I have on offer for somebody, and somebody can come to me, and there can be some exchange that may be money or maybe a token of some sort in exchange for a good or service. So what we try to do with this particular API, which is the Web Payments API or suite of APIs, is we try to capture that basically in the web browser. So right now, how we do this on the web or how we buy things out on the web is basically by filling out forms. And again, forms have been around for a really long time. So going back to I think it was like HTML2 or something added forms. It might have been like HTML3, who knows? Like some random version like 20-something years ago added forms. So we've had a ton of practice in filling out forms, right? And forms are really cool. So here's your typical form that we would find on Amazon, for instance. So what's really cool about forms is they give us type controls. So you can say input type text, which is nice. And then you can have things like, input type of text, but this thing auto-completes to an address. You can also auto-complete to a city and things like that. So the browser starts to know about forms. And what's neat about forms and how this relates to accessibility is that forms are fairly accessible. By virtue that we can actually give these things a type, and we can kind of indicate or tell the browser what our intent is. Having said that, anyone who's tried to fill out a form on a mobile device or even just regularly on the web, it's really annoying. So we have to fill these forms out over and over again as we shop around the web, or as we buy things, or as we engage in commerce around the web. So here's a typical example of for instance, when we say that the input type is email. So for email, for instance, you can see on an iPhone, we get the @ key. Then we have, for instance, input type for telephone. And again, we get a nice input type for telephone. So there are some limitations, though. Is that we can't, for instance, say that this form is for a particular activity. We can't say, this form is for payments, or this form is for, logging in. So even though we can capture structurally and semantically the items that make up the form, we can't say this form will achieve this particular task. So anyway, what we can do is do cute things. Like I said, that we can combine the type, for instance, text, and we can say, hey, this is text, but it actually means like the given name or the family name. And the same for telephone. For telephone, we can say, hey, this bit of like this input is for a telephone, but it's also for like country code or for like national, for area code, and so on. So when we put that information together in the browser, what we get is the idea of autocomplete. So here, hopefully you can see this animation. Everybody would have seen this before. Essentially, just filling out a form, or the browser like using heuristics and also autocomplete to be able to auto-populate a form. So like, name, you might press the down key. It might give you an option to select like from a number, so Timothy or John Doe, and then it automatically fills in the details. That's pretty cool. So that's really useful because it means now we don't need to do so much typing. So this is fine, right? So let's take a step back. So we know from a web browser perspective, or even from like just a general browsing perspective, that's like pretty cool. It's already very useful that the browser remembers this kind of information. But when we take a larger look at what's happening around us with relation to technology, we can now consider again, like, what is the intent of the form? If we're going to buy something and we have this amazing technology like on Android and on iOS and so on, then we can essentially consider like, proprietary payment methods for doing these things, which do them much more effectively, as you'll soon see. So I'm sure like most people will have, like I said, like an iPhone or an Android device, and hopefully you've used something like Apple Pay, Android Pay. Maybe some of you have used Microsoft Wallet. You might not even know it, but you may have used it. It's actually been renamed Microsoft Pay, I think now. But essentially, like if you have an Xbox, you by default have one of these Microsoft Wallet accounts by virtue that you've inputted your credit card into the Microsoft ecosystem. So wouldn't it be great if we could leverage some of these? So the first step to actually do this on the web actually came from Apple. So I don't know if any of you have seen, for instance, Apple Pay. So Apple Pay is a really neat solution because what it shows is a very like foolproof way of integrating into a web browser, so into any shop, for instance, and then you can pay with Apple Pay. So Apple Pay is a proprietary payment system, and it's also a proprietary Apple API. But what's really cool about it is that it like works together with your phone. So for instance, you can use Face ID in order to do a payment to verify that it's you. Otherwise, you can use the fingerprint scanner on the phone to make a payment as well. And this works like seamlessly between the browser and the device. And the other really cool thing is this whole idea of tokenized payment. So when you pay, for instance, you can see on the screen somebody's paying $128 for something. It's not transferring the credit card number in this particular case. What it's transferring is a token that represents that particular amount. That's really cool because it's cryptographically secure and it's fairly fraud-proof. Again, we can't make the claim that it's like 100% fraud-proof, but it's pretty darn close. There's all these systems at play. With relation to Apple Pay, and I'm sure with Google Pay as well, where there is a relationship established between yourself, your bank, and Apple to actually make this whole thing work smoothly. That's really like amazing. So obviously getting that on the web would be like super awesome. And that's where we come in. So that's where the W3C comes in, and also in relation to like the W3C members. So in particular, this has been a collaboration between Microsoft, Google, Mozilla, Facebook. Apple's also heavily involved in this effort, as well as all the major credit card companies and so on. So this community got together and we decided to put together this API, partially based on all the amazing work that Apple had done, and also other, obviously, credit card companies coming in or banks and so on with a whole bunch of experience to actually create, this new API. So what's really cool is that everyone's on board with it. And I should have included here is Facebook as well. So, the Facebook native app may at some point gain support for this API as well. So, but it's been an amazing success in terms of how browser members have managed to come together and actually support this API. So I won't claim, so if you go and look at Can I Use, you'll see that we're not quite at 100% support, but we're pretty damn close. And I'm going to walk you through the parts and what's actually, as I mentioned, this is a really new API. So we're still developing it, and we have it at what's called candidate recommendation phase, which means like we've asked all browser vendors to now go and experiment with it. And that's exactly the phase that we're at the moment. So we've been getting all this amazing feedback from companies like Stripe, from Shopify, just like big commerce sites or big drivers of commerce, and are like, oh, okay, we should tweak this because this doesn't really work for our customers and so on. So we're currently gathering that feedback. In Mozilla itself, we're doing a bunch of user studies at the moment to see like, okay, how do people shop in different countries? And we're integrating all that feedback back into what I'll show you in a minute is an actual demo of the payment sheet, and you'll see how this all relates. And you'll see differences between, I'll show you differences between Google and the differences between Mozilla. So yeah, let's have a quick look at how this actually works. So I'm going to just drop out and jump into Firefox Nightly. So this is only in Firefox Nightly right now. This is not a final thing. What I'm going to show you is literally like today's build. Fingers crossed it's all going to work. The design that I'm going to show you is not the final design, but you'll get a pretty good idea of what it looks like. So here we have a payment API demo. And what it's going to allow us to do is, this is from the merchant's perspective. So we're going to say like our shop accepts, just zoom in a little bit. So it accepts MasterCard and it accepts Visa. So we could choose other credit card networks that we accept. Next, we're going to set up the total for the thing that's being purchased. So let's say we're going to set this to say 65. And what we can do is pick a currency as well. So generally, we'll give an ISO currency code. So right now, we'll leave it on US dollars, but we could give a euro or whatever. So these are all the well-known and standardized currency codes. Display items are essentially the things that are being purchased. So we could, for instance, buy some shoes. And we would say, let's say the shoes cost $20. They're cheap. And as we have the options, so we can say, hey, in order to complete this transaction, so for instance, I'm buying shoes, so I need to be able to send them to somebody. So I need to have the buyer's name. I might also need the person's phone number in case like I need to obviously ship them the shoe. I might need their email as well because I want to send them an invoice and say, hey, here's like your proof of purchase. And obviously, I'm going to need to send them, I need to ship them the shoes. So, and then we can say like shipping type, you can pick them up from a store. I'm just going to ship them. We're going to use delivery. So just set it to shipping. And we'll add a shipping option. So here we have a default, the worst prompt shipping for, let's say, $30. And we'll make that the selected one. I won't add any more. But we can add as many shipping options as we want. So we'll just one more here. So let's make that $5, the mere prompt shipping. Can make payment allows the developer or the merchant to actually check if a payment can be made or if there's instruments registered. So payment instruments registered. So if there are credit cards registered that can actually make this payment. So you don't want to show like the payment requesting, which I'm about to show you, before, there's no point in showing it if the person can't actually make a payment. And lastly, let's now, given that we've checked all those boxes, we'll click the Buy Now. And here we have, for instance, the Firefox payment sheet, which comes down. So now you can see the total that I set up. So now we have a nice accessible set of elements. This is literally just built using HTML within the browser itself. And we can select an address. Again, we can now see the two shipping options that we had. So again, nicely keyboard accessible. So for payment methods, this is like just using a fake credit card. So I'll just give like 1, 2, 3 as a CVV. contact information. See what's missing. So it's saying I'm missing my email address. You can again see the forms, again, using normal HTML forms. And it's asking for this to be, so this is required. So I'll just put like Marcus at marcusc.com, and I can update that. And now you can see the forms become valid, or the payment sheet itself has become valid, and now I can pay. And what comes out of that is this nice JSON structure, which you can then post to a server. So I'll just put that up again. So just so you can compare the Firefox payment sheet. And again, I'll very quickly just use the defaults for Chrome. I won't add any display items. And I can just click Buy Now. And you can see in Chrome, very similar payment sheet. So all the browsers provide these payment sheets. And we can just, like, for instance, given that I have everything already like set up, I can just hit pay. So you can see with essentially 2 clicks, and by entering the CVV for my credit card, which we don't store in the browser, we can essentially make a purchase very quickly. So again, so like buy now, pay, 1, 2, 3, confirm, done. So that makes the shopping experience consistent, accessible, and very easy to use across websites. So the other really cool thing is that, you know, the browser is able to synchronize these credentials, so your credit card credentials, your credit card information across multiple browser sessions. So you can have it on your mobile phone. So once you enter it, for instance, on your phone, it will automatically become available on your desktop browser and so on. So that's really cool. So let me go back into my slides. So that's both Chrome and Firefox itself. So let me now just walk you through the actual API. So you've seen how it works, and you've seen the different bits that we can put together. So let's look at this under the hood. So if you were a developer, so hopefully people who are watching are developers, because we're going to get really code heavy now. So we're going to walk through the whole API, and we're going to see really cool things that you can do. So again, to create a payment request, all you do is you just construct a new payment request, and you provide method data, details, and options. So the methods is how you pay for things. So for instance, using credit cards, so you can say, like, we have a special key that you use called basic card, which indicates to the browser, hey, this payment can be made with a credit card or some kind of card. But at the same time, we provide multiple methods. So you can say, like, hey, I support credit cards, and I also support Apple Pay. Details. So the second argument is what is being bought. So that's usually like the details of, like, the shoes, for instance, that you're buying shoes. And then options is the things that are needed to complete the transaction, which is like, hey, if you're buying shoes, I need your shipping address. So I need to be able to ship something to you. So I'm going to need your address. I'm going to need some billing information or something like that from you. Or I'm going to need an email. So here we see an example of 2 payment methods, as I mentioned. We have the basic card, which is like, I want to pay with a credit card. And you'll notice I crossed out card types. So this has been quite an interesting discussion we've been having recently at the W3C. I'm only showing you this this idea of card types right now. And this is the, like, you can see supported types. This may be going away. There's a number of, like, issues with distinguishing between a debit card and a credit card, and it's not actually possible to do it computationally. So we're thinking of actually removing that. So you'll only be able to use supported networks. But right now, because it's supported in browsers, I've left it in there. So anyway, for the payment methods, you can see we can say, like, hey, I support, you know, you can buy stuff from my shop, but you can only use a Visa and a MasterCard. I don't support Amex. And then you have this, like, the second object, which is these this, like, example.com. This could be like Apple Pay, and this could have, like, this custom data that is used to make a payment. So I'm not going to go too much into detail into the custom payment methods. So again, you can see here in the merchant accepts. So you can see we said that Visa and MasterCard are the accepted methods, and we actually show the little logo there. which is kind of nice. So then the user knows like, okay, which card can I select? And we can also, in the browser, identify the card, which also helps, again, to make a purchasing transaction quite quickly, because we can filter out the cards that are not actually supported. Cool. So let's now talk about the payment details. So for the payment details, what we can do is actually give each transaction a unique ID, which is kind of nice. So if you're doing invoicing or whatever, you can do it directly through the API. So you can identify, okay, this is the actual transaction that we're like putting through. The next thing we can do is the total. So we can define the total. So the total due, for instance, in this case, it's $65, and you can define the currency in which that's in. So what's really cool here, again, from an accessibility perspective, is the localization aspects that take place. So as we pass that up to the browser, we can actually take the system settings and like, as you can see, like in Firefox, down on the bottom left-hand corner, we can use the right, currency symbol. And you see Chrome does the same thing, and it also is able to localize all this correctly. So total, like if the payment sheet is in a different language, like in French or whatever, or some other language that uses a different convention, this, not the label, but the amount itself can be correctly displayed, which is kind of nice. Okay, so the display items is an array, so you can add as many things as being purchased. So again, like shoes, or we can just say like subtotal. So we can just add that in as particular value. Here's an example of like sales tax. We can say, okay, sales tax is again $5 US. So pretty simple, and you just keep stacking these on, and you just end up with the display items. Now, where Firefox and Chrome do things differently is that in Firefox, we right now are experimenting not displaying these items. But in Chrome, you can actually see an order summary, which may or may not be useful. We haven't decided, at least on the Firefox side, whether this is useful. So at the moment, we are experimenting to see whether we actually will support these or not. But you can see them in Chrome. You can see your order summary there, which is kind of nice. So a quick look at shipping options. As you would expect, they're, again, very similar. You can give them an ID. So here we have like standard shipping using ground shipping. And we also have like drone shipping, so you can have a different value for each one, and you can just keep stacking them up. So again, you can see how these show up. So in Chrome, you have this nice sheet that you can go into and actually like use keyboard to go up and down, or just tab around to select the one you want and just hit space. In Firefox, we're using a drop down. So different approaches to how we present this information to users and how we allow users to access them. So what happens when in the API, so when there is a shipping address, sorry, when the user selects or changes shipping address or shipping option, it actually fires an event. So there's a whole bunch of different events that we have here. And what needs to happen here is generally like, the user will like select their address, and then we send that information back to the merchant, but we actually like redact that information. So we don't send like your whole address. We like take out parts of the address, just so not, like we will only send like the country and the postcode, but not like your exact address, which is enough information for the merchant to calculate shipping costs, for instance. So they can calculate shipping, and they can also determine like if like you might be, so for instance, I'm in Australia and I might try to buy something from Europe, and then that like I might try to buy a refrigerator from Europe, and then it's like, okay, we don't actually ship from Europe to Australia, which would make sense. So sorry, we can't ship to that address. So anyway, this event allows you to do really interesting things. Like you can also update the total if like you actually do ship to Australia, but it actually costs more to ship to Australia than shipping within Europe. We can also do cute things like this is kind of common in Australia, where if you use like, for instance, an MX card, you might need to actually charge more because the fees are higher. So we can actually express like credit card fees through a thing called modifiers. I'm not going to go into too much detail about modifiers, but just knowing that that capability is there, you can do like cute things as well. They're like, well, like if you pay with this special credit card, like if you pay with an Amex or you pay with a Visa, you get a free mug. Like you could add additional things related to how the user pays. So if there's incentives, then you can use that as a way of like incentivizing somebody to use a particular card. Again, that is a little bit far-fetched, but it's there for if anyone wants it. Again, we're still evaluating whether that's a useful thing. And lastly, you remember the last option is this idea of requesting like an email, requesting a name, requesting the phone, and requesting shipping. So that's expressed through this last little object, which is just a little property bag. So as you saw when I was demoing this to you before, the whole like required thing came up. So here's what it looks like. Again, in Chrome, is like, hey, you need to input your email address. Again, it works just like a normal HTML form with input, having an input that's required. So it won't let you proceed until you actually fill that out. So it's nice because it can, you know, in a semantic way or an accessible way also convey that to a user like, hey, this field is required and needs to be filled out. So both auditorily it could be done, and it also can be done visually as well. So let's talk about how, you know, once the user clicks, let me try that again. Let's talk about how when the user clicks pay, what actually happens. So what we get back is this payment response. And usually what we do with the payment response is we need to validate it. So when we validate, for instance, a shipping address, we can do two things. We can basically, you know, produce an error. So I can't ship to this address. You know, so as a generic like catch-all for this address is broken. And then we can say, for instance, Farmville is not a real place. This postal code is unknown in this country. And then we can send that up to the browser to display these things to the end user. So the API provides this, you know, very, very fine-grained error reporting. So anywhere that the user can type, we have a little field that will match that, and we can send that information up. And what's even really cool, or even cooler, is that if you want the browser to do that on its own, you can just put in empty strings and say, these things are broken in some particular way. You know, hey, browser, just display like your generic error here. Like, so the browser will know like, okay, city's broken, and I should prompt the user to like, hey, check your city. So each browser will handle that differently, what the default message is. But again, it's done in a way that just signals, hey, this is broken, which is kind of nice. So that's essentially payment response. So payment response coming from, you know, the action of hitting the pay button. Cool. So now jumping down, once we've validated, we can now say, we get back this response, we validated it, and now we can actually say, hey, everything's cool, and we can response.complete, so we can complete the transaction, or otherwise, if it's not good, we can fail. So either it'll succeed or it will fail. And there are situations where something, like it may go through or something's gone wrong, and we can actually complete the transaction with unknown. So this gives a little bit of flexibility. And actually unknown is used for, I don't know if some of you may have experienced these thing called 3DS payments, which are like a Visa thing, 3D Secure, I should say, which is like, hey, you can do this payment, but you need to enter a password, or you might get sent an SMS. For cases like that, unknown actually works really well. Cool. So a really cool thing that we added really recently, this is not in any browser that's like shipping at the moment, but it's being implemented in all the browsers, is the ability to retry a payment. So you can imagine a situation where like you're like, hey, I'm going to buy this fridge. Everything seems great, and and then the person like is on a train and they go to pay and the connection cuts out. So there's a network timeout, or or another example might be like, hey, I'm going to buy this fridge, and then the shipping address is actually a PO box. So you're not going to send the fridge to a PO box. So we can do both network error validation and data error validation, and we can retry payments based on just getting bad data. Or the other thing might be that the credit card details that you get back, or that the merchant gets back, they may be invalid. So the credit card date might be wrong, like the expiry date and so on. So this allows us to, again, prompt the user to fix things. So let's look at how that works. So again, we have a response, and we're going to recursively validate a response. Should be fun. So what we do is we start by validating the request and the response. So are they both good? Are they in a happy state? And we get back a bunch of errors. And what we also have is a promise for the user to fix some things. So just keep those two in mind, because this is going to be loop-de-loop. So we're going to use some recursion here. If we have no errors, then we're done. We're good. We know we're in a good state, so we can finish this payment. However, if, for instance, the shipping address has an error, then we can ask the user to fix that. So we can say, hey, user, using this custom code fix field, which I'll show you in a little bit, can you fix this request to shipping address? And then that gives us back a promise. And we're like, okay, the user, we're promising that the user will fix this thing. And we might do the same with the payer as well. So we can say that there was payer errors, which means like their phone number was bogus, or their email address isn't a valid email address. So it's like pointing to some random origin or a random domain that doesn't exist. So again, we can ask for them to fix that, and we just wait for that. And then all we do is promise.all, wait for these things to be fixed, and then we retry. Given the errors, we retry. And then we recursively validate again. So they give us back a bunch of stuff. We check if it's okay. So again, if we were to go back up to the top, we would check if there's no errors, and then we will return. So eventually, we go around in a loop. There's actually, given that this is all theoretical code, given that there's no actual implementation, I actually there's an actual little bug here, which should be like recursively validate response and request, which is all good. But let's now look at the fix field just very quickly. So we can say like fix this field either on request or response, the event. So it's like shipping change event, which captures like a shipping address change, and some custom validator to validate our data for us. So so again, we add an event listener, say, okay, listen for like shipping address change, customly check whether the response to the request was okay based on that type. So based on that particular validator. And then we can basically do an update with, which is part of the eventing APIs that we have for payments, basically telling the user that, hey, this stuff is wrong. Then we just wait to check if there's any errors. If there's no errors, then we're good, we're fixed. So we resolve and we're done. Cool. So that's essentially like I would say like 95% of the API. There's a few other little events, but it all works the same. So we've worked really hard to, it's not an easy API by any stretch of the imagination, but we've worked really hard to make it really consistent. And once you get going with it, it's actually really quite easy to use. So once the bits are all in place. We have great examples on MDN. We've been working really hard with the MDM team to make sure that we have really good examples there, and we continuously strive to improve those. So let me give you a little summary of what we've discussed. Basically, that so again, what's cool about this API is that the browser instruments are securely stored in the browser, but we don't store like critical bits of information like the CVV. But it does allow us to do potentially interesting things like have those things stored in the cloud, so we can actually like send them across the browser securely, and then it just makes payments much easier. The browser's UIs, I think in both Chrome and in Firefox, and possibly even in Safari, I've not checked, but these are all built using either HTML itself or native accessible UI components, which is great. So they're already like, the same stuff that you all use is the same stuff that we rely on. And we actually really cool thing in Firefox, we just switched to native web components for this. We were actually using a polyfill, and we literally dropped it like 2 days ago, I believe. So we're now using native web components with HTML forms. So again, I can't emphasize that enough. We in Browserland, we use exactly the same stuff that you all use. So we rely on all the same accessible forms and accessible elements. As I said, we leverage the existing autofill infrastructure that's in the browser. We leverage HTML for validation. Absolutely leverage the underlying web platform. It's all like, at least in both Chrome and Firefox, it's all like CSS, HTML, all the things. We have that nice feature that I talked about the default localized error messages. And what's really cool about this API is that it's a true progressive enhancement as well. So the idea is that if you already have a form, you can use that can make payment API to tell you whether the user actually can make this payment, and if they can't, you can show the traditional form and just use the normal everyday flow that you would use normally in when a user is making a purchase. So I want to talk a little bit about the future in the last few minutes I have left. We're getting really close to finishing this API, but we're not stopping here. Credit cards are just one way of paying for things, and Apple Pay and so on, again, are, they're fantastic, but there's more opportunities out there to pay for things in different ways. So, for instance, Bitcoin might be one way, or cryptocurrencies might be one way of doing that. And then there's all these other, depending where you live, there's potentially tens to more methods of paying for things. So it'd be nice if we could bring those on board as well. So other people use PayPal, there's WorldPay. So again, it really depends on where you are. So we're looking at ways of leveraging those, and those things that we call payment handlers. And what we're trying to do is bring together this idea of having a URL to identify a way of paying for things. So we can say android.com/pay, and then using web manifest to actually make this linkage that, hey, this is actually an application, like a web application that can handle payments. So I said, I don't want to use any particular company. I'll just use bank.com can handle payments for you. So whatever your bank is could handle these payments because they have your credit card information already. So what this allows us to do is basically have a complete ecosystem that covers basically using native apps as well as web apps, as well as the browser's information all together to actually perform payments, which is kind of cool. So I'm not going to go into too much detail into what I'm showing here, but the idea is that on Android today in Chrome, you can actually register a native app to be a payment handler, which is really cool. So you don't need to have a web app. You can always use whatever's built into the OS as well. So on an Apple machine, Apple Pay is the default thing that you pay with, and then you have Microsoft Wallet, as I mentioned, or Microsoft Pay over on Windows machines as well. So the idea is that we can try to integrate into all those. We're also cooking up this idea of having a service worker be a thing that handles these payments as well. So with this whole payment handlers idea, so potentially you have Etsy makes a request saying, hey, I support wallet.com, and wallet.com wakes up and goes, hey, yeah, I can handle that payment for you. And it could provide the information to Etsy. So again, this is something that's still quite experimental. It's actually in Chrome, this whole payment handlers API, but it's still very much under development. So here's a little summary again of where we've come with web payments. We have forms and autofill as, we'll call it the past, which is really the present. Then the present is we're trying to get this whole payment request thing happening. And then in the future, we want to have this whole payment handler API with cryptocurrencies and try to make that as usable and accessible as humanly possible to bring everything together. So that is it for my presentation. Hey, that effect.
That was wonderful, Marcos. Thank you.
No problem.
Dennis, do we have a couple questions for Marcos right now?
Yes, we do have a couple questions. Marcos, you mentioned that this is still being worked on and tested, and you're currently getting feedback. Can you share some insight into some things that have maybe changed through this process based on some of the feedback you have received?
Absolutely. Oh, I wouldn't even, I could be here, like do a whole talk just on that. So one really interesting one. So again, the whole idea of the, let me think of one that's like more user focused. So for instance, in Germany, it turns out that we didn't know this, that credit cards are not very heavily used online. You know, and in Brazil, they have particular ways of paying for things. So we thought like, well, we didn't think, we knew that like, we can't take this one payment sheet and like apply it everywhere. So what we're doing in Firefox is rolling this out in North America first. So we're going to do an incremental release, and we're going around. So we literally have people going to people's houses and seeing how they shop online, which is like amazing. So it's like, it's really cool. So we just send like teams around. Like our team's about like at Firefox is about 10 to 15 people, I think. But yeah, we have an amazing researcher that is part of our team, and she goes and does all the user studies. And but anyway, so you know, the feedback that we get as we see how people like shop online, it's like, okay, we need to tweak these things. So that's coming from the users directly. So as I mentioned, like we removed the display items in Firefox. So we're going to see if like, hey, maybe they don't need that. Then from merchants, people like Shopify, you know, we thought, for instance, hey, wouldn't it be cool if we do have the display items and then we have like tax, and you could actually say, hey, this thing, because it's very common in the United States, like you like in places where you're given a price that you think is like the final price, but then it's like, oh, we need to add 18% tax on top of that. And then it's like, oh, the totals actually changed. So you need to know like how much tax you're actually paying. We thought it would be cool to actually make an explicit distinction. And then it turned out that that wasn't such a great thing. Another thing is like billing addresses are really important in the EU because you calculate VAT based on the billing address. So you need to actually have that information first. So right now we have a pull request to actually add billing information. So anyway, these are the huge range of problems. And another like crazy one is this whole like card types, which I mentioned, the one that I had crossed out. Card types are like insane. Like the way to determine a card, whether a card is a debit card or credit card, is you need to like basically contact the bank and ask a bank, hey, what kind of card is this? So there's like these databases that people have collected, which allow you to do these lookups, but they're like full. Well, no, I wouldn't say full of errors, but the error rate is like 10%. It's too high. Like we can't give that to users and like try to make this distinction. And also, it turns out that it's illegal even in some places to distinguish and do pricing based on card type. So that's why we're also like looking to get rid of it as well. Okay. Hopefully that answers your question. Some of the fun things.
That is perfect. And thank you very much for those examples. Actually, we are out of time for any additional questions. If you liked this session, hit that like button. And don't forget, you can subscribe to YouTube/Inclusive Design 24 for future notifications. A reminder that Inclusive Design 24 is brought to you in partnership with Barclays Access, the PayCAO Group, Intopia, Microsoft Edge, and Open Access Technologies. And we thank our sponsors, DQ Systems. Inclusive Design 24 will be back on the hour with Thaddeus Cabron speaking about addressing trauma and stressor-related disorders.